So that was number 3. Number 4, redox reactions. They're called oxidation reduction. So oxidation reduction reactions. We also call them redox for short. Oxidation reduction reactions, they are reactions involving the transfer of electrons. So a lot of different types of reactions are considered redox reactions. So for instance, single displacement reactions are redox reactions. I'm going to talk about combustion reactions next. Combustion reactions are redox reactions as well. Now, oxidation reduction reactions, a lot of them involve the reactions of a substance with oxygen. So for instance, an example of one would be just hydrogen gas plus oxygen gas produces gaseous water. Let me put a G here, G here. This is considered a redox reaction. What ends up happening is electrons are being transferred from hydrogen to oxygen, and it forms a compound. Another example of a redox reaction is when you have iron plus oxygen gas. This is considered a redox reaction as well. This is the formation of rust. This is when iron rusts. I can say iron rust. Basically, you have iron and oxygen coming together to form iron oxide. Not all redox reactions involve oxygen gas. Some of them are just when you have a metal and a non-metal. So I'll say involve elemental oxygen. So these react with O2. So if it reacts with O2, we can go ahead and assume it's a redox reaction. Other types is when you have a metal and a non-metal reacting. So sodium, which is a metal, plus chlorine, which is a non-metal, reacts to form sodium chloride, which is, remember, this is just table salt. When they come together to form the table salt, metal, non-metal, we say that's a redox reaction. So I'll say another way. So the first type is if it involves O2. The second type is when you have a metal plus a non-metal. Remember, metals, when they react with non-metals, metals lose electrons, non-metals gain electrons. So remember, this is going to be a positive and a negative coming together. One gained one lost one. And then in general, another way we can say we have a redox reaction is just when one substance transfers electrons to another. And that's what occurs when we see single displacement reactions. Remember, the single displacement says we have A plus BC gives me B plus AC. Basically, my A transfers its electrons to C. And then the last type of reaction I want to talk about is when we have Combustion reactions. Combustion reactions, combust. Combustions reactions, like I said, they are a type of redox reaction as well. And what happens is anytime you have a carbon containing or carbon hydrogen containing compound, when it reacts with elemental oxygen, it's going to emit heat. So we say it's an exothermic. No, don't run out of ink. Reaction. We say that it's an exothermic reaction. And remember, all that means is that it emits or gives off heat. And what ends up happening is we're always going to form carbon dioxide and water. So, an example, if I have a carbon hydrogen containing compound like CH4, remember this is methane gas. Methane gas in the presence of oxygen gas. And remember, anytime you got the O2 here, remember that makes it the redox reaction. It's always going to form water, which is a gas, plus carbon dioxide, which is a gas as well. If I balance this properly, it should look like this, 2H2. So, if I had a question that says, write the combustion reaction for octane, remember octane is the gas, the liquid we use for our gas, our gas that we put in our vehicles, in our cars. And octane has the formula of C8H18. And it's a liquid. If I wanted you guys to write the combustion reaction for octane.
No way.
And this is all.
Bien, güey, ¿tú?
Muy bien, ¿qué me cuentas?
Nada, güey.
All right, and this was all I gave you. You guys should be able to write the combustion reaction by saying, okay, I know it's a combustion reaction. It's a carbon hydrogen containing compound. So the way it always looks is that I'm gonna say C8H18 in the presence of oxygen gas, it's going to form water plus CO2. And these are both gases. And these are all gases, really. And if I balance it properly, it looks like this: 2, 25, 16, 18. So remember the whole point, you got oxygen gas, water, and carbon dioxide for combustion reactions. Sometimes the carbon hydrogen compound contains oxygen as well. We'd still consider it a combustion reaction like C2H5OH. This is ethanol, which is a liquid. In the presence of oxygen, it's still going to form carbon dioxide plus water. Gas, gas.
I have one question, Professor.
Yep.
Do we see that CO2 as a whole or separate? Like we have 18 carbons on the right side, on the left side we have only 16 carbon. Above one.
I just wrote it backwards. This should be 18. This should be 16. Thanks for pointing that out.
Do we
Okay.
do the complete ionic equation and that for these?
So no, we don't write the complete ionic and net ionic equation in this case because these aren't ionic compounds. These are molecular compounds. Remember, carbon and hydrogen are both nonmetals. So these are all, they don't break apart into ions. And on top of it, they don't have any aqueous solutions. Remember, for the complete ionic and net ionic, we needed to say aqueous so it can break apart into its ions.
Oh, okay.
But that's a good question. Let's take a break. Let's take a 15-minute break, and then we'll come back and do a bunch of practice problems. And then that'll be all for today, and we'll get ready for the lab for tomorrow.